Hello everyone. In this video, I'll be covering demo problem for finding the peak of this curve. This curve has the form y equal to f of x, where f of x is 5 minus x minus 2 the whole squared. If this were a math class, then we would be taking the derivative and setting it to 0 in order to determine the peak of the curve, correct? Since we are going to use computers to solve our problem, we are simply going to try out various input values for x in order to determine the highest value for y. All the demo problems that we covered so far presented the very obvious use case for while loops, which is counting. This particular example is going to give you use case number 2, which is about searching through a set of values in order to determine the best possible value. We are going to simply search through the possible values for x in order to determine the best value of x, which produces the highest value for y here. For doing this, we are going to combine conditionals along with while loops. Let me switch to Jupyter Notebook. We are going to get started by defining f function. F function here is simply 5 minus x minus 2 the whole squared. Let me run the function definition cell. Then I'm going to call the function by passing 1 as argument here. What will be the output? That will be 4, correct? That's because 1 minus 2 is minus 1. Minus 1 the whole squared is simply 1. 5 minus 1 is going to be 4. What would be the best possible value for x for this function f of x? That would be 2. That's because 2 minus 2 is 0. 0 squared is 0. 5 minus 0 is simply going to be 5, correct? Let's verify that by calling the function and passing 2 as argument. The second part of this expression here is always going to be positive, immaterial of the value of x. That's because we are squaring. So the best possibility that you can have is this part of the expression being 0. That's because you're subtracting that from 5 here. So how can we determine this best x and best y value using while loops? First of all, we'll have to decide the range for the x values here. Let's say that we want to run the while loop from minus 5 to 5. I'm going to initialize loop condition variable x to a value of minus 5. Then my loop condition is going to be while x is less than or equal to 5, correct? I usually like to use the print function call to check the sanity of my loop before I actually write the other lines of code. This is one other hint for incremental coding to test whether your current version of the program is working correctly or not. There is a slight problem with this while loop, correct? I did not update the loop condition variable x here, so this is going to cause an infinite loop. I still want to run the cell because I want to show you how you can handle infinite loops in Jupyter Notebook. You'll have to go to kernel, then press interrupt, or alternatively you can press the interrupt button down here. That will make sure to stop the kernel. After that, you can go back and fix your problem. In this particular case, that would be x plus equal to 1, correct? Then I can go and do kernel restart and run all, and that will solve my infinite loop problem here. Observe that now we are getting the output as minus 5 through 5 here. So how can you deal with infinite loops in script mode or interactive mode? You need to press Ctrl C on your keyboard, which is the kill signal. That will terminate your program execution and you can go fix your while loop issues. What do we want to do with these values? We want to be able to determine the corresponding y, correct? I'm going to call function f by passing x as argument. Let me capture the return value into the variable y. I'm going to display x and y for every iteration of this loop. Looks like we're getting 5 as the y value for x here. How can we determine the best x and best y? We are going to do that by introducing a conditional. We are going to predefine a best underscore x and best underscore y. And for every iteration in the while loop, we are going to compare the current value of y with the previously known best underscore x and best underscore y. The easiest way for you to initialize best underscore x would be just by saying the current value of x. Best underscore y is going to be f of x. This is not a bad assumption because we are just initializing x to a value of minus 5 here. Let's think about what we need to do inside the while loop with respect to the conditional. We'll have to check if the current value of y is better than the previously known best underscore y. We can do that by saying if y is greater than or equal to best underscore y. If that is the case, then we want to update best underscore y and best underscore x, correct? What will be the new value of best underscore y? That will simply be y. Similarly, the new value of best underscore x would be x here. Let me try to print the values for best underscore x and best underscore y outside the while loop. Observe that the print function call is lined up with the while keyword here. So the print function call is outside the while loop. I'm going to add in a string saying best x and y values are. I'll have to use a comma because best underscore x has an integer type. If I want to use the plus concatenation operator, I'll have to explicitly typecast best underscore x and best underscore y into an integer. Let's try to run the cell again. Looks like we are getting best x and y values is 2 and 5, which is the correct output. Let's try to understand this search process, which is the second use case for a while loop, by adding more print statement. I'm going to add a print function call inside the if condition here to say that we are updating best underscore x and best underscore y. Let's rerun the cell. Observe that we are getting updating best underscore x and y for the very first iteration itself, which is going through x value of minus 5. That's because we have the condition of greater than or equal to here, correct? If I were to remove that equal to, then the first update statement will go away because minus 44 is not greater than minus 44. Best underscore y is initialized to f of x is minus 5, so it is initialized to minus 44. What would happen for iteration number 2 of this while loop? X will become minus 4. The corresponding y is minus 31. Minus 31 is greater than minus 44. So you're going to update the best underscore y and best underscore x. Similarly, you'll keep that going until you hit the input of x equal to 2 and the corresponding y is going to be 5. For the rest of the while loop, we are not going to update best underscore x and best underscore y anymore. That's because the rest of the values for y are lower than the value of y corresponding to the input x here of 2. So let's try to change this f of x function slightly. I'm going to do that by saying the function is now f of x equal to 5 minus x minus 2.5 the whole squared. What will be the best value of x then? That would be 2.5, correct? Do you think our program here is going to output 2.5 as the best value for x here? The answer is no to that. Why is that the case? That's because we are not running our while loop to check the input value of x to be 2.5. Our while loop increment is just a whole number of 1. So we never execute the while loop for input x value of 2.5. So you're only going to get an approximate output from the current version of the while loop here. How can we fix this? We can change the increment to a smaller value, say 0.1. Notice that you're getting a lot of output. That's because you're getting way more iterations from your while loop. If you have increment as 1, you're going to just go from minus 5 to -4 to -3, etc. up to 5. But if you have 0.1 as increment, you're going to go from -5 to -4.9 to -4.8 to etc. up to 5, which is going to be way too many iterations for us to have the print function calls here. So I'm going to comment out the print function call in line 8 and line 11 here. Let's try to rerun the cell. Looks like we are getting 2.5 and 5.0 here, which would be the expected output. What if I wanted to lower down the increment even higher? I can try 0.01. Observe that the computer is very fast even though we are going through way more iterations than before. What if I try a little bit lower increment by saying we have 0.001? That is still giving us a very quick output. Let me add in a couple of zeros. That's going to take a few seconds for the computer to go through because there are way too many iterations for this while loop here. Please make sure to understand the difference between the various increment values that I just showed here by trying those values out. I'll wrap up this video here. In the next video, we'll go through the next demo problem.